Again, welcome to CS 435 course. This is data structure and algorithm using Java. In these lectures, we're going to cover the linked list ADT. Again, this is second part of our linked list lectures. So again, we're going to learn about linked list ADT, and also we're going to learn how to construct a double linked list and also the circular linked list. So in our previous lectures, we discussed what is a linked list, and also we said linked list consists of nodes, and we implement a simple linked list which normally have only two parts of the nodes. The first part will carry the information, and the second part will be the address that the node is pointing to. So in this section, we're going to start with the implementation of the simple linked list. Then from there, we move on to the concept of double linked list and also the circular linked list. So here we start with a diagram, which is the class diagram for linked list as ADT. Normally, when we are designing ADT system, which is the abstract data types, we don't include the instant variables. But as we know, the instant variables again will be the node. So we may have the info part, and also we may have the address part. Normally, the info part depends on the data type that we want to store in the linked list. And then the address part will be the data type of the node. So again, as usual, normally a class diagram, the first row will be the class name. The class name here is called again linked list ADT. And again, it's an interface, abstract data type. So the second row should be the instant variables, but normally with ADT or interface, we don't include the instant variables. Our main concern here is the methods, designing the method. So first we have the method name cron. I think we went through this in our previous lectures. This will make a copy of the list, the linked list. Then we also have a method to check if the linked list is empty. And we call this method is empty list. We also have to initialize list. Normally in the class diagram, the positive here means again, these methods are public. And the returning type is on the right side. So for example, cron, the returning type will be the object type, which again, in this case would be the class type. Then it's empty list, normally will return true or false. So the returning type is Boolean. And to initialize a list, here we are going to initialize the list to some either empty or with some items. So it doesn't expect no returning value. So we use the void. Also, if you want to print an items in a list, the returning type also is void. And the method length will return the number of nodes or items in the linked list. So the type will be integer. Then we have the front method to check what is in front of the linked list. The type is still, which is the generic. So the type depends on the information that we are storing in the linked list. Then the back will tell us what is at the rear of the linked list or the back of the linked list. The returning type also depends on the type of data we store in the linked list. Then we have a method to search an item in a linked list. This will return Boolean because if we find the item, we are going to return true. If we don't find the item, we'll return false, which means the item is not in the linked list. Then we have the linked list to insert first. This means we are going to set in front of the linked list, and also insert last means we insert from the back of the linked list. And actually we implement these two methods in our first lectures, how we can build a linked list forward and also backward. And we say when we are building a linked list forward, we insert the node again from the back. And when we are building it backward, we insert the node from the front. Then we have the method also to delete a node. So here we say there are two types of linked lists. We have the sorted one and also unsorted one. The algorithm, again, to implement some of the operation may differ, or It depends, but may differ for sorted and also unsorted lists. Therefore, we're going to define the linked list class as an abstract class. So here we say a linked list class have two derived classes. So here we are going to have the unordered linked list and also ordered linked list. So the whole concept here is that we want to implement a linked list class, but we know a linked list class can have two types. We have a sorted and unsorted. A sorted means, again, the items is in the linked list has been arranged in some order, either maybe ascending order or descending order. That's increasing or decreasing order. Unsorted means, again, we can insert the item anywhere. They are not in order. So if we can create a linked list class, then we may create unordered linked list, which is the items in the linked list are not sorted. Then we have the ordered linked list. Then they can derive from the linked list class what method they will use. Because both unordered and ordered linked lists may use the same, they are using the same operations. But again, maybe if you want to do insert, insert means we have to, with the ordered linked list, we have to look for the location where we have to insert the item since we put it in order. But if I'm using insert operation in unordered linked list, I'll just insert it anywhere, the easiest part, whether front or back. So each node of a linked list must keep track, again, of the data as well as the next node in the list. This structure, again, is the simple linked list. As we said in the previous lectures, a simple linked list may have only two parts, the information part on the node, and then it may carry the address of the next node that is pointed to. So that's why the node may have two instant variables. One will be the data that we are going to store in the node and the address of the next node that is pointing to. Now, if we are doing double linked list, then we may have three instant variables. The node that is point to backward, the previous node, and also the next node. Then we still have the data. So we may have previous node address, next node address, and then the data. So to simplify operations such as insert and delete. So this may help us. And also linked list node is defined as protected and generic. The reason why linked list node is defined as protected, since we know, and this is the concept of inheritance. So any of the class that inherit from linked list, or they have an inheritance relationship, then they can each directly access the instant variables protected. So this is the structure of the linked list node. So we have the linked list node and we have the linked list class. So as we said, linked list class, we use the linked list node. So we have a relationship. And this is our linked list class dot linked list node. The node, again, have two parts, the information, which is T. T stands for the generics, we can have any data type, and also the address. So we call the address variable as link. And address variable, as we said, always it will be the class type. So the class name here is linked list class. So we have linked list class node, linked list class node. Then we call the constructor. Anytime we want to create a new node, we call the constructor linked list node. So we have two types of constructor, with parameters and without the parameters. Then also we can clone the nodes if we need more nodes. And if there's any data we want to print or represent it as a string, we can use the string again method. So this is a UML diagram, a class diagram of the class linked list node, and also the outer inner class relationship. So this is the class, the linked list class we use, because as we said, the linked list consists of nodes. So when we have the node class, anytime we want to set a new node in a linked list, we have to use the linked list node class to generate or produce the new node to be inserted in a linked list. So these are the instant variables again. Here we say the instant variables of the class linked list class. We have the class name first and the instant variable name first. Again, the type will be linked list node because the address. So this is the variable to store the address of the first node of the list. We make it protected because the inheritance relationship. Only the class that inherit with this class can directly access the class data members, the instant variables. Also, we have the last. So last will be a variable that will store the address of the last node of the list. Most of the time, the last node address or the last node always point to null also. Then we have a variable name count. This variable will store the number of nodes we have in the list. So anytime we insert an item into the linked list, we have to increment the count. Anytime we remove items from the linked list, we have to decrement the count. Also, we need the linked list iterators. As we know in Java, I have the class for iterators, and we normally use iterators objects to go through or transverse through an items, to go through an items, in this case, in a linked list. So an iterator is an object that produces each element of a collection of one element at a time. So an iterator has the most important two methods. The most important two methods. One is harshness, and the other one is nest. So harshness normally will check whether there is a nest element in the collection. So I can use harshness in the condition, and that will check if there's an element in the nest position. Then nest is the method that will move the item. So it will give access to the next element in the list. So we use harshness to check if there's items or element in the list and the next position of the linked list. Then we use the next method to get the element in the next item in the linked list. So this is our linked list iterators included here. So we have, again, we have the linked list class dot linked list iterator, which means again the linked list class is going to use the linked list iterators. And here we have the current, which will be the current address, and also we have the previous. This is our method for linked list iterator. One method we can use it to reset. So we can reset the whole linked list. And then we have a method next. This is the method we said it will give us the access to the next element in the linked list. As next, normally we return Boolean, either true or false. If you return false, that means we reach the end of the linked list. There's no any item in the next. If you return true, that means we still have more elements in the linked list. Then remove method can remove an item. And also we have the toString to represent the output in string form. So this is the relationship. We still have the linked list class. So linked list class inherit the linked list iterator, or you can use it. So these are the relationship between the two, same as the linked list class also have a relationship with the linked list node. Here we are going to use the iterator also, so iterator is included. So now this will be our final linked list class. First, we have the linked list node, the first and the last. This is the two at the front or back of the address. And also we have the count. This count will keep count of items in the linked list or the number of nodes in the linked list. So we start with the constructor, also the default constructor. So we have a linked list class, default. Our next method will check if the linked list is empty. And we initialize the list. We can print, we can check the length, we can check what is in front of the linked list. We can also check what is in the back, which is the back method. We can also make a copy of it called the cron method. Then we have our one. So this is again from linked list class up to the cron. We saw these methods already previously. So this is our new method now. Since we are going to use the iterator, we have the iterator method. And the type is a linked list iterator. So we can also search an item, insert in the first or insert last, or delete an item. So next we will go through the implementation, which is our main objective in these lectures. So to check if a list is empty, all we need to do is to check if the first node is point to null. Remember in the theory, we said that the first node is the special node that normally point to the first element in the linked list. So if first equal to null, that means there's nothing, there's no any element in the linked list. Now our default constructor means we are going to create a linked list with nothing, empty linked list, and because it's default. So which means we're going to set the special node that point to the first element to null. And also we're going to set the last to null also. Then the count is very important. We don't really need a count, but we are using the count in this implementation because anytime we need to know the number of nodes in the linked list, all we need to do is to return the count variable value. So anytime we insert an item, we may also have the count variable in the method to increment the count once. The same thing if we remove an item from the linked list, we may have the count in the method to remove item, and we decrement the count. So next is to initialize the list. Initialize the list is almost the same as the default constructor. Now the difference is that if I use the linked list in my program and set an item, remove, did some operations to implement some other work, when I'm finished and I still want to use that linked list object, what I can do is that I can call this initialize list method to delete everything from the linked list we have because I want to use it for something and I need it to be empty. So constructor normally means when I create a new linked list, it will automatically be called, or we can call it to create it. But if I have an existing linked list already, and this time I want to remove everything or make sure it's empty, then I'll call the initialize list to make sure everything is empty. So we can see that the code is the same as constructor also. We assign the first to null, last also to null, and make sure the count is 0, which means there's nothing. Now, next we want to print items in the list or the linked list. So as we said earlier in our previous lectures also, we mentioned that if we want to go through the linked items in a linked list, we cannot use our first pointer, which point to the first node in the linked list. Because if we use that and move, if I move from the first to second, then the first element will be the reference, which means we are going to lose it in the linked list. So the first thing we need to do is to create another pointer, and here we name it current. So current will be a variable that will go through the list or traverse the list. And the current type will be the linked list node. Then next, we set the current to the first. So we are starting from beginning. First is our special pointer that point to the first element in the linked list. Now, if we use the first to move through the linked list, then every time we pass a node, we are going to lose it. So we want that not to happen. So now we are going to use the current. So since we set the current to first, now we are saying that, okay, if current not equal to null, that means we haven't reached the end of the linked list. What we do, we print the item. So system.out.print the current, the position it is, print the information there. Then we have current.link assigned to current. And as we said in the theory, current.link means we move to the next node. Now, if I have current.link means I'll move to the next two node. So we assign the next node to the current in the pointer. So we let the pointer current move to the next node. Then we come and check our condition again. If it's true, then we reach the end. If it's not true, then we keep printing. So while current not equal to null is true, then we keep printing more. Then we move the current to the next node. Now when we reach the end, while current not equal to null, no, false is equal to null. We say the last element always point to null. So if the current reach the last element, it will point to null, and the while loop will stop. So this is the method we can use this method to transverse through the linked list also. But here we are printing, that's why we call the print statement first before we move to the next node. So if we are just transversing through the linked list, then all we need to do is to remove the print statement out. That's it. Then current.link assigned to current, the pointer will move to the next node. So the next method is to return the length of the, so the length of the list will be the number of nodes we have. As we said earlier, the count variable is keeping track of that. So here we just return the count. Now next is retrieving data of the first and the last node. So first we start with the front method. The front method would retrieve the data in the first node. So here we say return first.info. Remember, first is point to the first element in the linked list. Same thing, we have the variable last, and last is point to the last element in the linked list. So to know what is at the back, we return last.info. Also, we can make a copy of it, which is the cron. The cron will return a cron of the list, which is a copy of it. So here we say the current implementation of a cron method makes a shallow copy of the list. So next will be the definition of the class linked list class. So here we say, again, this is abstract class. The name is linked list class. Implement linked list ADT. Implement the abstract data type. So for example, in the first session, we say we're going to praise the definition of the class linked list node. Then we praise the definition of the class linked list iterator. Remember, we said the linked list class we use, and we're going to use the linked list node because the linked list class or a linked list consists of nodes. So anytime we need a new node, we use the linked list node or an operation on the node. Then we say we are going to use iterator. So here also we have the linked list iterator that again help us to transverse through the linked list also. So next also we're going to praise the definition of non-abstract method. So non-abstract method here means we are going to implement the method, write the code. And then the abstract method also can be here. So first we have the unordered linked list, the class diagram. So we have the unordered linked list, that's the constructor. Then we can search an item. We can insert an item in the front, which is the insert first. And also we can use the insert last to insert an item at the back. And also we can delete a node from the linked list. And the same thing also, the unordered linked list, we inherit from a linked list main class. So a linked list here, we may have the ordered and also unordered. So now let's see the method. The search method is to search if there's an item in the linked list. So the same thing, if we are searching an item, we have to go through the list of the item. And when we see the item, we'll return the position of the item or wherever the location of the item. So this means we need a variable again. This time we are calling it current again. So this current pointer will again go through the item. So here we say variable to traverse the list, which we call the current. Then we say we assign boolean to found. Now we are going to start from beginning. So we set the first to current. Since we are searching an item, we start searching from the beginning. So beginning will be first. So we assign first to current. So now current is set to point to the first node in the list. Now this is our flag variable. So we assign false to found. And now we say why the current not equal to null. And also we have not yet found, but found is false. Not found will be true. So if these two works are true, then we search the list. So how do we search the list? We say, okay, if the current.info, where the current is, the node, if the information in that node equal to the search key, what we are searching for, then we find it. So we set true to found. Otherwise, we go to the next item. So this will be current.link assigned to current. We go to the next node. Then when we go to the next node, the same thing, we'll come back here again to check if that current position, the next node that we went to, is not equal to null, which means we haven't reached the end of the linked list, and also not found. Okay, if that's the case, then let's search that node with the search key. If they match, which is equal, then we return true, which means we find the position, we find the item. Else, we didn't find it, they are not equal, then we move to the next node. Now, when we move to the next node, let's assume the next node is null. And we come here, we say, why current not equal to null? No, current is null, so it's false. So we are using AND operator. Since we are using AND operator, if the first condition is false, we don't even need to check the second condition. So in this case, we come out of the while loop, which means we reach the end of the linked list. So also we have the method to insert first. And the method name is insert first. So to insert an item, of course, we want to insert a node. The node carry our information, the data. So the first thing we do, we create our new node, a variable to create a new node. Then after we create the node, we want to set in the linked list. Remember, the pointer is what helps us for the location. So the next thing we do here, first of all, we use the new keyword to dynamically allocate the memory space for the new node. Normally, we can write this as a one line. So for example, I can say linked list node, new node equal to new linked list node. This is a constructor with arguments. So the argument is new item and also the first. So this will create and insert a new node before first. Then we assign the new node to first. Then we say, okay, if first not equal, if first equal to null, which means the first list was empty, then the new node is also the last node in the list. So this statement here basically means if I set the first node into the linked list and that last equal to null, then again, there's only one node in the linked list. So we finish, we assign the new node to last also because it's only one element. So it will be the first and it will be the last. But if this condition is not true or is false, that means we have a node inside already. And since we insert in the first, it means the last is still what is there. We don't change it. And remember, we have to increment the counter. So this counter variable, anytime we want to know the number of nodes in the linked list, we just return the count. Same thing we can set at the last. So here also the same steps algorithm. I want to set a node in a linked list. So first thing we need to do is to create the new node. We use the new key to dynamically allocate the memory space for the new node. And since we are inserting last, it means we are setting at the end of the linked list, and the last item in the linked list will point to no. So here, the new node, constructor linked list node, we have the new item and also the address will be no. So now we say that if the first equal to null, which means the list is empty. So if the list is empty, the new node that we insert, it will also be first and also be last. So we say the new node we assign to first and the new node we assign to last. Else, we say the last dot link equal to new node, because this else means this condition is false, which means we have a node. So if we have a node in the list, then the new node that we insert will not be first, but it will be last because we set at the end. So that's why we say, okay, else the new node is only the last dot link, and we assign the new node to last. Again, this section here should be part of the comment. So last node here is set last to point to the actual last node. Then also the same concept, we are inserting at the last. Since we are inserting, we have to increment our count. So we increment the count. So now to delete a node, these are the 4 different possible cases that we can have in a linked list. So for example, if a list is empty, then we don't need to delete anything. Now, if the first node is the node to be deleted, there must be some strategy we have to take. Also, if the node to be deleted is somewhere in the list between, there must be different strategy. Now, if the list does not contain the node to be deleted, there's some strategy. So these are the different 4 possible cases. List is empty, we want to delete, or the list does not contain the node that we want to delete, or the first node is the node to be deleted, or the node to be deleted somewhere in the list. So we'll go through each one later on. So for example, this is the order linked list now. We saw the unordered. So the order linked list, we have the class order linked list. You can see the methods are the same with the unordered linked list. We have the search, insert, insert first, insert last, and delete node. Now to search, here, first of all, what we do again, as we said earlier, we have to go through the items in the linked list. So we need a pointer. So we use the current variable to go through the list. And now we set the current to point to the first. Now, if current not equal to null and we didn't find, then what we do? We are searching for an item. So our main goal is to compare. First, we create a temp variable here, and we assign the info to it. So the information in the current node is inside the temp. So now we can say that if temp dot compare to the search key greater than or equal to 0, that means we find the item. We set the true to found. Else we didn't find it, so we move to the next element. Now, if found, we'll return what is found. So here we say current.info equal to search item. We assign it to the found, then we return the found. So to insert an item in an order linked list, as we said earlier, the previous one we did is unordered. We can set in the front and we can set at the end or the last section at the end. But if we have ordered, the section can be, we have to be careful. We can set at the front, at the last, also between, because we are putting it in order. So the first thing we have to look for the place that we have to insert it. Again, this is ordered linked list. So here we say to insert an item in an order linked list. First, we should find a place for the new item. It can be front, back, between. Then insert the item in the list. So we should consider these three cases. The list is initially empty. Well, if the list is initially empty, then we just insert. Doesn't matter, we can do insert front or insert rear, etc. Or the list is not empty and the new item is smaller than the smallest item in the list. So if the new item I want to insert is smaller than items in the list, it means I will insert it in the front. It depends again if it's the ordered is ascending or descending. If it's in increasing order, the small ones will come to the front. If it's in decreasing order, then small ones will be at the back. So the only thing we should know here is that ordered list insertion is the only made this difference. Also, the list is not empty and the new item is larger, then we set it at the large element. Again, here I'm doing increasing order, ascending order for ordered linked list. So here we have the insert first. So we insert a new item. Then the same thing, insert last. We already have the method insert, so we insert the new item. Then you should consider 4 cases if you want to do a delete node also. Here we say the list either is initially empty or the item to be deleted is contained in the first node of the list, or the item to be deleted is somewhere in the list. The list is not empty, but the item to be deleted is not in the list. So we consider again the list is empty, or the list is not empty, but the item we want to again delete is not in the list, or the item to be deleted is contained in the first node, or it's contained within somewhere in the list. So this is the concept of double linked list. Again, here we are not going to implement it. In our next lecture, we are going to implement the double linked list. We will do lab work also on it. So here, just the theory. We know a simple linked list, every node have the address of the next node and also the information part. With the double linked list, we can see from the diagram here, the node may have address for the previous also, and then the next. So which means with the double linked list, we can traverse very easily opposite direction. We can either go forward or go backward, since we have the address of the previous and the next. So here we see a linked list in which every node has a next pointer and also the back pointer. With a simple linked list we implement, it's only have the address of the next. So a double linked list can be traversed either way, in that direction. We can go forward or backward. Now with a simple linked list, we only traverse forward because the pointer is only one pointer pointed towards forward. So this is the double linked list node. As we say here now, we have 3 instant variables. Simple linked list, we have only 2. So the T is the generator, the information we are storing. Then we have the double linked list, the node. This will be the address for the next node, and then back will be the address of the previous node. Now here we have the instant variable of the class, double linked list class. So again, we are using count again because that will keep count of the items or the nodes we have the linked list. We have two positions, either the first and also the last. Because again, it's a double linked list. The first address, which point to the next element. The last address will point to the previous. So the default constructor means we are going to press no for both the first and last, and also set the count to 0. It's empty. We'll check if the first equal to no. Always same, so it's same as a simple linked list. The first point to no means we don't have anything. To initialize the list, also we initialize both the first and last to null, and also make sure the count is 0, there's nothing here. Then to check the length of the list, the same as simple linked list, so we return the count. And also to print means same as simple linked list. We can print forward or backward. It depends on what the direction of the pointer. So for example, here when we create our variable that will go through the linked list, we set it to first, which means we are going to start from the first element down. We can also set it to back, which means we are going to start from the last element opposite direction to the first element. So here we decided to use the first. So while current not equal to null, we print the item, we increment to next element. So we can see that the print method here with a simple linked list is the same. The only option with the double linked list is that we can set the current to back, then we can print opposite direction. Also, we can reverse an item in a linked list. The best way is using double linked list to reverse if it's double linked list. So here we have a double linked list, the current. So we set the current to last, and then we print in reverse order. So if current not equal to null, then just print the item and move the current one step back. So we also have the search method. So we set our flag variable found type is Boolean. We also set our current variable that we are going to use to go through the elements in the linked list. So we set again the found variable to false. And also we set the variable to transverse through the linked list to first. So we start from the beginning. And now we say that if the current not equal to null and also not found, then we go through the items. Any first item we get, so current.info, we assign to temp. So we say temp.compare to. So we compare the item in our first node that we visit to our search key. Now we say if it's greater than or equal to 0, it means we find what we are looking for, that position. If not, then we move the current to the next node. So it will be current.next assigned to current variable. Then here we say, okay, if found, then we return. So we say current.info.equals search item. We assign it to found and we return the found. So this is again the first and the last element, which is almost the same as a simple linked list also. Again, this is a double linked list implementation. The first element, we just return first.info, the last element, last.info. So again, same as simple linked list. And also insert the same condition we may have as a simple linked list. First, we can consider if the section in an empty list, if the list is empty. Or if we are setting at the beginning, or if we are setting at the end, or somewhere between the linked lists. Then deleteNode, we're going to consider the following 4 cases. We don't want to delete an empty linked list. There's nothing here. or the item to be deleted is the first item in the linked list. And also if the item to be deleted is between somewhere in the linked list, or the item to be deleted is not in the linked list. We consider these 4 cases to implement the code. Again, we are going to see all this code in our next lab work. So that's the concept of a circular linked list. Again, as we said earlier, a linked list in which the last node points to the first node. So double linked list means we go in both directions. So with the double linked list, every node have 3 parts. The address of the next node and also the address of the previous node or the back node. But with circular linked list, it's almost same as simple linked list. But when we reach at the end, instead of the last node to point to no, the last node will point to the first item in the linked list. So it's going circular. So it's more convenient to make first point to the last node. So with all the implementation we have done, this is an example of what we're going to do in the class, or we may use it as a homework assignment. We are going to write a program using the linked list concept. Here, the program will consist of a list of videos that can be rent or returned. So for example, first we want to know how many inventory of videos we have. So we should keep, to make this very easy for us, we should keep the count variable. So when the user returns a video, we increment the count. It's more or less like insert operation. When the user borrow video, it will be a delete operation. So here we are going to create a list of videos owned by a store. Then we show the details of a particular video, the name of the video, you can add the authors, etc. And the more information you have, the more variables, instant variables we need. So we can print a list of all the videos using the pointer, maybe a second pointer to go through the list of the video every round we print. So we have that method. Also, we can check whether a particular video is in the store and also maintain a constant. So check whether a particular video is in the store. Again, in this case, we can use the search. Checking something is a search. So we use the search method. We go through the list with a pointer. The first item, we check if it's equal to what our search key until we reach the last video. So again, this will be implementation in the classroom. So again, wish everybody the best. And again, thank you. See you in our next class.